So today we're going to talk about solving quadratics in a new way. We've talked about how to solve quadratics by factoring, how to solve quadratics by using the square root property to square root both sides and therefore isolate x. Today we're going to talk about kind of putting those two things together. We are going to go through a process called completing the square, and that will allow us to then factor and solve in ways that we already know. Okay? So let's take a look. We have this as an example of a quadratic equation, and then here you'll see all of the steps for solving by completing the square. All right, and what I want you to know is it's only steps 2 and 3 that are actually completing the square. And when we say completing the square what? Well, completing the square means that you are looking for a perfect square trinomial. A perfect square trinomial is a quadratic that has a special form. It's where the first term, this is an example, the first term might be something like x squared, where the first term is squared. And the last term, let's say, is also squared. We'll call it 4, okay? Because the square root of 4 is 2. So this is a square, a perfect square. So the first and last terms of this quadratic are both perfect squares. And then to get the middle term, we're going to do 2 times these two terms. So the middle term would be, it's going to be 2 times the root. So the square root of 4 is 2. The square root of x squared is x. So in the middle it would be 2 times x. So that's a perfect square trinomial. And we talked about those in a previous chapter. So if you need to go back and review perfect square trinomials, what they are and how to factor them, go ahead and do that. Today we're going to talk about what happens when we get some gnarly looking quadratic like this and we want to turn it into a perfect square trinomial where the first and the last terms are squared. All right, so let's take a look at that process. First thing that we're going to want to do is move all of the constants to the right. Remember, the last term of a perfect square trinomial is a perfect square number, and this number, 24, is not a perfect square number. And even if I were to add 2 and move this over, it still is not a perfect square number. So there's not really any way that I can factor this nicely to be able to use the square root property and solve for x. So I'm going to go ahead and move this number out of the way. That's my first step. Just get it out of the way so that now I'm left with my quadratic term and my linear term. I'm going to leave a blank space where that used to be, and this is going to be 22. So now I have a trinomial on the left. Well, sort of. It's incomplete. I don't have that last term, that C term for my trinomial. I need to create one. I need to complete this trinomial in a special way so that it becomes a perfect square trinomial. All right, so this is how we're going to do that. First thing we're going to do is divide the middle term by 2. Divide the middle term by 2. So you're going to take this, divide by 2. 6 divided by 2 is 3. There you go. Easy, right? At that part. Next, the next step is square it. So take the number that you got when you divided by 2. You're going to pop it into parentheses and square it. 3 squared is 9. 9 is our special number. 9 is our magic number that will create a perfect square trinomial. So this is the number that's going to go here. All right, we're going to add it here. But this is algebra, and I can't just do something on one side of the equation without doing it to the other. So that's why our next step is add it to both sides. So I added it here in my empty space. I need to add it over here as well. Now let me go ahead and simplify this a little bit. Bring down my quadratic term, my linear term, and my new perfect constant term. And then 22 plus 9 is just 31. So far, so good. All right, now we are going to factor the PST, the perfect square trinomial. Because now I have this special trinomial where I can take the square root of m the square root of m is m because this could be m times m, okay? And the square root of 9 is 3 because this could be 3 times 3. So you take the square root of that first term and that last term, and then you're going to ask yourself, if I take these two, if I take a 3 and an m, and I do 2 times 3 times m, will I get my middle term? Well, we specially engineered this trinomial so that you will, but that's how you can tell that, yes, this is in fact a perfect square trinomial. And if it is a perfect square trinomial, it follows a special pattern. That pattern is that it will factor into a binomial squared, where the sign of the binomial will match the first sign of the trinomial. So I'm going to use addition. So the sign inside is going to match your first sign of your trinomial. If this was minus, my binomial would be minus. If this is plus, my binomial is plus. But then what are the two values that go inside? Well, I'm going to take one of these roots, m, and one of these roots, 3. Ta-da! M plus 3. That's my factor, okay? And it's squared. So if I do m plus 3 times m plus 3, I would get my original trinomial here, okay? And that's what I wanted. Now, it's equal to 31 still, okay? So now we have factored our perfect square trinomial, but we haven't done anything else. The next step is going to be solved by the square root property. The square root property just says to take the square root of both sides. So I'm going to square root here, and I'm going to square root here. Again, staying consistent with the idea that whatever I do on one side, I have to do on the other. My square root and my exponent will cancel. So those are going to cancel each other out, leaving me with x plus 3 is equal to the square root of 31. Now, I can't actually do the square root of 31, so I can just leave it under the radical. That's perfectly okay. Just leave it under the radical, and that's fine. That's accurate. Remember, though, that it is always plus and minus. Okay? It's always both of those. And then all you have to do is isolate the m by subtracting 3 from both sides. Now, m is alone. That's good. That's what I wanted. But I can't actually do this subtraction because they're not like terms. One has a radical and one doesn't. So I'm going to put my constant term first, plus or minus my square root. And since that's all that I can do, that is as simple as it gets. Take a look at the second video to see us work through some of these problems together.